We are solving a problem from simple harmonic motion. Let us see what is the problem is. If the length of the simple pendulum is increased by 69%, by how much percent its time period is affected? That's the question, right? So we shall know the relation between time period and length of a simple pendulum. We have derived just in the other video, previous video, the time period of a simple pendulum is 2 pi into root of L by G. We know 2 pi is a constant, acceleration due to gravity at a given place is constant. Then the relation between time period and length of the pendulum is time period is directly proportional to square root of L. Then T1 by T2 is equal to square root of L1 by L2. Now he is saying if the length is increased by 69%, that means L2 is L1 plus 69% of L1. That's what he meant to say. How much is that? L1 plus any percentage can be converted into number by dividing with 100. 69 by 100 of L1. That is L1 plus 0.69 times of L1. That is, if I take L1 common, 1 plus 0.69. That is 1.69 times of L1. Now I know L2. So I can find out the time periods, right? So let us continue the discussion now. So you can write T1 by T2 equal to root of L1. In the place of L2, I will write what we have found. 1.69 times of L1. L1 can be cancelled. That implies T1 by T2 equal to square root of 1 by 1.6. T1 by T2 equal to square root of 1 is 1. Square root of 1.69 is 1.3. 13 are 169. So 1.3 into 1.3 is 1.69. That implies if you cross multiply, T2 is 1.3 times of T1. So it's very clear. T2 is greater than T1. That means time period is increased. By how much time period is increased? To get that, I can say T2 minus T1. T2 is 1.3 of T1 minus T1. If I take T1 common, 1.3 minus 1. That is 0.3. So T2 minus T1 by T1, which is called as a fractional change in the time period as 0.3. If you want a percentage change of the time period, I have to just multiply the right hand with 100. 0.3 into 100. That is equal to 30%. So the problem says that if length increases by 69%, its time period increases by 30%. That's how we can solve this problem. Thank you for watching.